Hey there, my Charger family. This is Mrs. Boyd. Today we're talking about the parts of quadratic graphs. Let's just get started. Quadratic functions can be written in three forms. One of these forms we're not even going to look at. That is the middle one, vertex form. You can save that for Algebra 2. First, we want standard form. We're going to write in function notation. So f of x equals, and then we have ax squared plus bx plus c. Quadratic graphs involve a quadratic function that has an x squared in it. That's a quadratic function. A standard form here, like I said, f of x equals ax squared plus bx plus c. Factored form is going to be f of x equals a times x minus m times x minus p. That'll make more sense a little bit later on, I'm hoping, fingers crossed. The shape of a quadratic function is called a parabola. That looks like it should be parabola, but it's parabola. And it can present in two ways. It can face upwards or downwards. So let's graph these. I've just given you two tables of values, and we're just going to graph those points. So first is 0, 1, 0 left and right, 1 up, 1, negative 2, 2, negative 3, 3, negative 2, and 4, 1. So our parabola is going to look a little bit something like that and go facing upwards. That means it opens up. This opening where it looks like a funny shaped cup that would catch a drink or the rain. When it opens up, we call that facing upwards. We can also face downwards. Let's try that one out. Negative 5, negative 2, negative 4, 1, negative 3, 2, negative 2, 1, negative 1, negative 2. So that one is going to look like this, where it's like a hill, like an umbrella. If the opening is down, it faces downwards. So these are the two options for what a parabola can look like, facing up or facing down. Parabolas are symmetric about a central line called the axis of symmetry. I'm going to abbreviate this with AOS because axis of symmetry is too many letters for a mathematician to write. The axis of symmetry cuts the parabola in half vertically through the equation of the form x equals, here it goes, negative b over 2a. When you think about b and a, we look back at the original quadratic function in standard form, ax squared plus bx plus c. So this a is right here, the very first number when it's in standard form here. And b is right there in the middle with the x. So negative b over 2a. We want to find what the equations for the axis of symmetry are for these three graphs, and we're going to do so by finding the center and making an equation that says what that value is. So what I mean by that, this first graph is the middle right here where it splits it down the middle is on the y-axis. So we draw our axis of symmetry, a dashed vertical line like that. And you can see that this half of the parabola is in a mirror image to this half. The x value where this line is 0. So that means our axis of symmetry is 0. Let's do another one together. We've got this parabola facing down. The center to me looks like it's going to be right along here. So we draw our dashed line vertically right there. And then we find the x value at that line. That's x equals -2. And that's the equation for our axis of symmetry. Your turn to try one. Pause here and give that a whirl. All right, it looks like the center of our graph is right here. Splits that parabola exactly in half. So we draw our dashed line vertical where that is. And our axis, the equation for the axis of symmetry is x equals 3. 1, 2, 3. Perfect. All right, that's all for the front. Let's flip it on over. The axis of symmetry intersects a parabola at only one point, also known as the vertex. It's like the tipping point for where the direction changes from down to up or up to down. If we have a maximum vertex, it's the highest point on our parabola. And that's if it opens down. That's got a vertex, a maximum right there. Excuse me. A minimum vertex would be the lowest point. And that's in an upward facing parabola. So the vertex would be right there at the bottom. The vertex is where the range of values begin, listed as y is less than or equal to a number or y is greater than or equal to a number. So when we write our domain and range, it always has to do with the vertex. So let's put together all the things we know and give this graph some details. First, the axis of symmetry. Looks like it's right here on the y-axis. That means it's going to be x equals 0. Axis of symmetry is always an equation. Always, always. It'll be x equals something. Vertex is the very, very bottomest point here. And that is a coordinate point. So 0, 2 looks like the vertex. Minimum or maximum? Well, like we said above, if it opens up, then it will have a minimum. The domain. Every domain for all parabolas is going to be all real numbers. You can write that one of three ways. You can write that all real numbers, which again, that's a lot of words for a mathematician. You can write that all real numbers, or this is the way I was taught and learned in college, 2 lines with an R. That stands for all reals. The range, like I said, we're going to use our vertex in this case. We're always going to have y in our range. And then the y value of the vertex, I'm going to leave some space here and then write that y value of the vertex. Now, when I look at the parabola, are the rest of my parabola above 2 or below 2? They are above 2. So above means their values will be greater than. So y greater than or equal to 2. The y value of the vertex, if it's a minimum, it's going to be greater than or equal to. If it's a maximum, less than or equal to. I know it's a lot of info. You can totally do it. Try the next one on your own. I know you're just getting started, but I think you can do it. All right, axis of symmetry. Dashed line, that's the worst one ever. It's going to be x equals -2. That's -2, I believe. The vertex this time is at x is -2, y is 0. Is it a minimum or a maximum? It's a maximum. because it opens down. The domain, as we said, is all real numbers. That one's awful, so let's try it again. There we go. The range, like we said before, it's going to have a y. The y portion of the vertex is 0. If I look at my parabola, all of the values that are on my curve are less than 0. So that means the sign for the range is less than or equal to 0. Hooray! Let's do one more on your own. You can totally do it. All right, this one, axis of symmetry. Looks like it's right there. That's x equals 2. Vertex, way down here. It's not exactly on the line, but we're going to pretend it is. So that's at 2, -4, maybe. Minimum or maximum? Definitely a minimum. Opening upwards. The domain, as always, all real numbers. Let's fix that ridiculousness. There we go. The range, remember, y, the y value of the vertex. The rest of the parabola is -4 or up. So it's going to be greater than or equal to. All right, kids, I hope this makes all sorts of sense to you. Reach out if you have questions, and I'll see you soon.